Section 8.8 is about factoring by grouping. And so what we're going to do is you're going to be given 4 terms, and your first step is always looking for the greatest common factor. So remember, I'm looking for a number I can divide 3, 12, 2, and 8 by. Well, I would check my smaller numbers. Can I divide by 3? Yes. But can I divide over here by 3? Then the answer would be no. So my greatest common factor is 1. So I don't have to do anything for that step. The next step is, this is why it's called grouping, because you're going to group the first 2 terms together and you're going to group the last 2 terms together. You're going to find the greatest common factor amongst these first 2. So think of a number that I could divide 3 and 12 by, and that number should be 3. So I'm going to divide 3 by 3 and get 1, and I'm going to divide 4 by 3 and get, 12 by 3 and get 4. And since this was negative 12, this is going to become negative 4. Then I also see that I have n's involved. So remember, if it's n cubed, that means I have 3 n's. And if it's n squared, that means I have 2 n's. So I circle what both of them would have in common, and I end up getting 2 n's that they have in common. So I would also take out an n squared. So remember, when I am taking out n squared, that is going to leave me with 1 n from this first term, and then when I take out n squared from the second, that takes out all of them, so I won't have any n's on the inside on this second term. Then I'm going to look at my second grouping. So now I'm going to look at 2n minus 8 and find the greatest common factor there. I'm going to divide by 2. So I get 1n, and I get negative 8 divided by 2, which is negative 4. Now the trick with this is that every time you do this, the stuff that you get inside of the parentheses, those should be the same. So when you get ready to write your answer, you should have a set of parentheses that ended up being the same. So this set will go here. And then the 2 terms that were left on the outside of the parentheses, you're going to put those together and make its own set of polynomial. So I would have n minus 4 as being the same, and then 3n squared plus 2 gets put together as being the different piece. Now, if the GCF is other than 1, you'll want to put it out in front. But since ours is just 1, you don't necessarily have to put it there, but it's not wrong if you do. Alright, you're going to pause the video and try the next one. So on the next question, you have this polynomial, so you're going to look for a greatest common factor, and you should have found that the greatest common factor was 1. I'm going to group the first 2 and the last 2 together and find the GCF. So the GCF of the first 2 should have been 2t squared. So when I divide by 2t squared, I would get 4, and then taking away 2 t's is going to leave me with 1 t here. Then I'm going to divide 14 by 2 and get 7, and I'm taking away both t's, so I have no t's left on this second piece. Then I'm going to find greatest common factor of the second 2 terms, or the second group. That greatest common factor is 5. So I'm going to divide 20t by 5 and get 4t, and I'm going to divide 35 by 5 and get 7. Notice that this set of stuff that's inside the parentheses matches, which is what has to happen. So if it doesn't match, then you've made a mistake somewhere and need to go back and try and find a different greatest common factor. So when I write out my answer, greatest common factor goes in the front, so since it was 1, you don't necessarily have to have it there. My 2 terms that were different are going to go together, and my same term is going to go at one spot. So I would have 2t squared plus 5, and then 4t plus 7. Alright, let's look at one more just so you have a variety of examples here. So I just want to show you that sometimes there is a greatest common factor other than 1, and I also want to show you what happens when your first term is negative. So on this, notice that all of these can be divided by 4, so my GCF will be 4, but I also have q's on everything, so my GCF on this piece is going to be 4q. So what happens when I divide everything by 4q, I end up getting negative 1q cubed for this first one. And then when I divide this by 4q, I get 2q squared. divide this by 4q, I get negative 3q, and I divide that by 4q, and I get 6. So remember, you always want to check for that GCF because you want to make sure your numbers are smaller, and you want to pull that out from the beginning. Now I'm going to do my grouping. So I'm going to norm my GCF for the time being, and I'm going to do my grouping where I match up the first two and the last two. Now, any time in your grouping that the first term is negative, you need to pull that negative out, otherwise it will mess up your signs. So since this is negative, I'm going to pull that out as a negative 1, and I'm also going to pull out a q squared because they have two q's in common. So I'm going to divide this by negative q squared, so I just get positive q. And I'm going to divide this by negative q squared, so I end up just getting a negative 2. Then for my second grouping, I also have a first term that's negative. So again, I'm going to pull that negative out with my GCF, but this time I can pull out a 3, so I'm going to pull out a negative 3 for my GCF on the second grouping. So when I do that, I end up getting positive 1q, and I end up getting a negative 2. Now notice that this and this inside of my parentheses match. If you don't pull out this negative on those first terms, these will end up not matching, and then stuff will get thrown off. So now I'm going to write out my full answer. So the parentheses stuff was the same, so I'm going to pull that out. Then my two terms get put together, so I get negative q squared minus 3. And then don't forget about that GCF that we had. So that needs to go down there in the front. Okay, so factoring by grouping, you will have 4 terms, but you still run through the same before that you need to check for a greatest common factor, and then you're going to group first two together and last two together and find those GCFs.